Okay. I'm going to start with this second problem here. And I gave you the hint, find intercepts. You know what you do? You write out what you're doing at every step when you do the problem. That way, you know what to do when you get into the test. Now, this won't be on the test, except I might put it on as an optional problem, right? Okay. But you're going to need to know how to do this. And it's really pretty easy if you practice the procedure rather than just writing down the numbers and the graph. You forget what you're doing. Okay. If you do it out of habit, write down the procedure. You write down, find the intercepts. That's your first step. Okay. And then find the long run behavior. Those are two steps. So you got why don't I ever leave myself enough room? I just can't seem to anticipate. Okay, anyhow. How do you get the x-intercept? That occurs when y equals 0. Because y, let's just draw a graph here. Because anywhere on the x-axis, the y-coordinate is 0. Now you need to understand that. If you don't understand that, ask an AI to explain it to you. Go to the testing center or the tutor center, ask somebody there to explain it to you. It's something you should theoretically have known for a long time before you started this course, but there's still time, so get it straight. On the x-axis, y is 0. On the y-axis, x is 0. If I ask you to plot the point 5, 0, where are you going to put it? Well, you're going to put it about here because the x-coordinate is 5 and the y-coordinate is 0. X-intercept when y equals 0. So x-intercept when this product is 0. Now, the only way the product can be 0 is if one of the terms, or one of the factors, I'm sorry, is 0. So this splits into, okay, now if x minus 3 is 0, then the whole thing is 0 because you multiply by 0, you're going to get 0, right? And if x minus 4 equals 0, that's an or. X minus 4 equals 0, or x plus 5 equals 0, or x minus 1 equals 0. You set each one of these equal to 0. You write these equations. Again, if you're just writing down -3, 4, -5, 1, that only works if you got x plus or x minus. If you look at the homework problems, you might have a 5x plus 7 in here or 7x minus. You're not going to just be able to read that off. You need to write out the equations. Okay. And what I pretty much see is people just writing down -3, 4, and some people even write down 3, -4, 5, which doesn't even make these things 0. Okay. So you want to write down the equations. If you write down the equations and solve them, you're going to get it right, and you're not going to make a simple mistake. Okay. You need to follow the procedure. And of course, I've outlined this procedure, but I'll outline it in a little more detail this time. Now, it's written kind of small. You should know what I wrote in there because you've seen it before. And if you look at Open Math, they're going to tell you the same thing. They might not write this out exactly the way I did. I want to see here 4 equations with or between them, okay? Because and or are very important words. You want to understand that it could be this, or this, or this, or this. It doesn't have to be this, and this, and this, and this, because it can't be, because these are all different, okay? It can't be more than one of them at a time. Well, that aside, you see this procedure, you need to be following this procedure, okay? If you get there without the procedure, okay, but I don't think it's going to stay with you very long. You just memorize here, well, okay, when I see this, I do this. When I see this, I do that, without understanding the concept. So you want to, and if you understand the concept, if you practice the concept by writing out what I say to write out, it's going to be easier, even in the short run. You got to write a little more, but you start getting the picture, start understanding it, okay? Okay, so you get x equals 3, or x equals, x equals -3, or x equals 4, or x equals -5, or x equals 1. Now, if you have a more complicated expression in here, you're going to have to do a little work to solve the equation. But these equations we can solve in one step, and I think everybody knows how to solve them. All right. So your x-intercepts are at these points. Why is y 0? Why is the second coordinate 0? Because we let y equal 0 in order to get this equation. These are the points that we get when we assume that y equals 0. Also, y can't be 0 for any numbers except these. Because for any numbers except -3, 4, -5, 1, none of these is going to be 0. And if none of them are 0, then when you multiply them together, you're not going to get 0, and you're not going to get a point on the x-axis. Okay? So now we can draw these points. Again, I prefer to label my coordinates like so. To get the labels away from the shapes I'm going to be drawing. And my scale isn't great here, but it's good enough. It's going to show me the behavior of this function. And I'm going to put a mark here. I'm using an X because it's quicker to write than a dot, and you can see it better. Okay? But you can put dots here, one way or another. And ultimately, you often want to label these. You want to label this point -5, 0, this one -3, 0, and so forth. Now that's x-intercepts. You get y-intercepts when x equals 0. So that occurs when y equals 0 plus 3 times 0 minus 4 times 0 plus 5 times 0 minus 1. Now you do that arithmetic 4 times, there's -12, there's 60, there's -60. No, sorry, there's -12, -60, 60. So we go ahead and decide that we'll put y equals 60 here. Now the scale for y is different than the scale for x. It really needs to be. If we'd used the same if y was equal to 1, this far from the axis, 60 would be up above the roof, okay? Or at least up in the rafters and so forth, okay? We can't do that. And with polynomials, you generally can't do that. You can't have equal scales. Okay. So now we've got this. If you write out these words and fill in the numbers and fill in whatever you need to fill in, and do that every time you do one of these, after you've done half a dozen of them, you'll know what you're doing. And you'll understand it in a way that sticks with you and benefits you during the exam. Okay, and final exam, it's going to be in the final exam too. As I said, it's not on the midterm as a requirement, but if it's on there, it's an optional problem. Optional problem means go ahead and try it if you think you can do it. And if it helps you, I'll count it. If it doesn't, well, nice try. I don't count it. Make sense? All right, now, long run. Open math tells you use your calculator or some stupid thing. And it's totally not helpful to most students because most students only understand numbers by what comes out of a calculator. Okay? And if that's you, try to develop more understanding. You can do it in this course. You can do it elsewhere, but I'm not going to assume that you understand numbers. Okay? I mean, I know you can do simple arithmetic and stuff like that, but can you really visualize and understand big numbers? It's tough. Okay? And it's something that just really doesn't happen in most school curriculum. So I can't assume it, so I do this. I said, well, the long run behavior first place, we get y equals x to the fourth. Okay, this x is going to end up multiplying this x and this x and this x. Now, you use a distributive law to do that, but that's what's going to happen. We'll expand this one, maybe. Or I'll expand something a little simpler, just so you're sure you see how it works, because you need to know, you need to be able to do that. But we're going to get an x to the fourth. Not only that, but we're going to get well, not even going to do that in my head because I'll make a mistake. We get x plus a bunch of other stuff of lower powers. The biggest power wins. If x is big enough, it's 100 times as big as everything else you get. Or it's 1,000 times as big, or it's 1,000,000 times as big. Okay. Now, again, not enough people, some of you do, I'm sure, but not enough people understand enough about numbers to really understand how that works. You can read open math and try to pick it up there. And if you have some understanding of numbers, some decent understanding of big numbers, then you can get it. But I'm not going to take class time because it's not going to do most people a lot of good. I'm just going to state that this is what dominates. What does a graph of x to the fourth look like? Well, if you know what you need to know for the exam, I mean the current exam, it looks like that. And if you don't know, review what we did when we did power functions. the week before last or whatever. Okay? You know, just make a table, -2, -1, -1/2, 0, 1/2, 1, 2. And see how higher and higher powers flatten out more and more and get steeper on the side, so they kind of approach almost a rectangular shape. Okay, for even powers, you get the same numbers on this side as you get on this side, because when you take the fourth power of a negative, you get a positive. Okay. This is what you get for a zoomed out picture. We talk about wiggles, because you know these things kind of wiggle. You got to wiggle to get through these points. You know, the graph might do this. It might come up here, it might go here, 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 up here. Okay. It'll wiggle, it has to get through all these points. It's got to rise and fall, rise and fall. I just call that wiggle. Okay. It's got to wiggle. Well, the wiggles go in a microscopic area near the origin. Okay. Well, zoomed in on this little circle here, we've got this. So here is our little circle. So we zoom in on this little circle and we say this. Have you ever used a microscope? I'm curious. If anybody hasn't used a microscope?
I have. We've had science classes.
Okay, zoom in. And of course you can zoom in with a camera, or, you know, you got all kinds of things that zoom in. Just imagine you're taking a picture of this from a long distance away. It's going to look like this. You've got a good optical zoom. You can zoom in and you're going to see this. Okay. This tells you what your long run behavior is. It'll wiggle in here and it'll do all sorts of things, but as you move out, it's going to go up this way, and you move out to the left, it's going to go up this way. So now we know what the long run behavior is from this. Long run over here. Long run over here. So whatever it does in between, it's got to end up going up here on this side. It's got to end up going up here on this side. Okay, well, the other thing is, these are all of degree 1. As opposed to like the 0 you get here, which would be of degree 3. Okay. This acts like a cubing function near the 0. These act like linear functions. And we just did a chapter on linear functions. You got a test that has linear functions on it. You need to know what linear functions are, obviously. Linear function has a straight line graph, which means we go through this 0 on a straight line, we go through this 0 on a straight line, we go through this one on a straight line, we go through this one on a straight line. So if we start from the left, we come down from our long run behavior. And we're gonna come down like this, and we're gonna go through this zero. But we gotta be curving around a little bit, because we're gonna have to turn around and go through this one. Now, again, if we zoom in with a magnifying glass or microscope and only look at a little bit of this curve, it looks like a straight line. Even though it's really curving, if you look at it close enough, it's a straight line, just like the earth looks flat unless you get away from it, okay? So we got to come up and get through this point. This is unlikely to be our highest point, okay? So we don't try to go through here and make this the highest point. We try to come up with a graph that comes down here smoothly, goes through here, comes around, turns around here and goes up. And I actually think the thing might come up a little higher than I drew it, but yeah, you can take a graphing calculator or Desmos, create a graph of this thing. You see, this is only an approximation. In calculus class, you learn to find this low point and this low point and this high point. In pre-calculus, you get this much of it. In calculus, you refine it just a little bit. And it's pretty easy. We got to learn little calculus. So that's the best we can do in this course. Unless well, there are ridiculous things we could do, but they aren't important enough to do. Okay. Learn the calculus, then you can refine the graph. All right, so that's how we do one of these graphs. And we write out these words, please. Every time you do one of the homework problems, write out the words. You'll have it. Don't just memorize, okay, I'm going to take the opposite of this, the opposite. Okay, because I might give you 5x minus 7 and 14x plus 38. Okay, you don't know what you're going to see. If you've got this procedure, it doesn't matter what I write in here because you'll be able to solve those equations. Okay. I could even put a quadratic x squared plus 7x minus 9. But we're just getting to where we're going to be. We've just learned about solving quadratic equations, okay? And I'm probably not going to do that to you in this test, although I don't guarantee it. Okay, if I do, it'll be just one incidental part of the problem. Write it out. Get used to it. This is what it all means. Now I'm going to do this one a little bit more quickly. And I'm not going to stop and explain things as much. I'm not going to exhort you to write things out as much. I'm just going to write them out. I'll abbreviate just a little bit. I could write x-intercept by myself that y equals 0 so that if y is 0, then this is 0. So that this is 0 and this is 0. Add 2 to both sides, you get x equals 2. Take the square root of both sides. Usually you'd want to write plus or minus, but since you're taking the square root of 0, plus 0 and minus 0 are the same thing. So we get x plus 5 equals 0, x equals negative 5. Now this has degree 1 or multiplicity 1. I say degree because the degree of this factor is 1. So we'll just say multiplicity 1. Here, degree 3. Multiplicity is 3. Okay, so this gives us the point 2, 0. This gives us the point -5, 0. And these are our x-intercepts. Why is it 2, 0? Because we let y equal 0, so we know that the y-coordinate has to be 0. We solve for x, and that's the x that gives us y equals 0. So 2, 0 is on the graph. So we have x equals 2 here, and we're going to have a 0 here. And then -5, 0. Okay, well, 2's there. -5 might be about here. Okay. Now, it's kind of important to remember what the multiplicity is. Because, and I said degree 3, multiplicity 3, for no good reason, other than in the last class, when I had there had a multiplicity of 3. It's x plus 5 squared, which means that the multiplicity and the degree are 2. So if I was confusing you by saying degree 3 and multiplicity 3, okay, it's 2. That's a 2, not a 3. Yeah, but there's a square there, so I just wrote that down without thinking. Okay, degree 2, multiplicity 2. Now, the point is, it comes from x plus 5 squared. X plus 5 squared is just the toolkit function x squared shifted 5 units to the left. So it's going to act like the x squared function shifted 5 units to the left. It's going to look like this. Or maybe like this, because it's also vertically stretched and possibly reflected. So it's going to be this way or this way at x equals -5. At x equals 2, it's going to go straight through. So if I draw straight through lines, it'll look like a big X, and I'm not going to draw that. Y-intercept. When x equals 0, you get y equals 0 minus 2 times 0 plus 5 squared, which is -50. Okay, well, I should just go ahead and put y equals -50 down here. There's our y-intercept. Something seriously wrong here, because that's not going to work. Never mind, that's going to work. Okay. Okay. Long run, I will expand this. X minus 2 times x plus 5 squared equals x minus 2 multiplied by x plus 5 times x plus 5, which equals x minus 2 times what? Well, x plus 5 times x plus 5 is x times x plus 5 plus 5 times x plus 5. This is just the distributive law. Now, x times x plus 5 is x times x plus x times 5, which I'll write as 5x, plus 5 times x, which is 5x, plus 5 times 5. So now we've got x minus 2 times x squared plus 10x plus 25. So what's that equal? It equals x multiplied by x squared plus 10x plus 25 plus 5 times x squared plus 10x plus 25. And that equals x times x squared plus x times 10x plus x times 25 plus 5 times x squared plus 5 times 10x, and I ran out of room again. It'll be 5 times 25. Now, I'm going to skip a step just because I need a little bit of room here. Actually, I don't need that much. But that comes out x cubed. Okay, I'll write it. 10x squared. X times 10x is 10x squared. X times 25 is 25x. Plus, write these in second line, 5x squared. Plus 50x plus 125. That comes out x cubed. Got 10x squared and 5x squared, that's 15x squared. 25x and 50x is 75x. Plus 125. Now that's really easy if you understand the distributive law and understand what I just did. If you don't understand it, look at that part of the video again. Look at what I'm pointing at. You'll be able to see it better, especially as I was blocking some of the board. Okay? But it's very straightforward. Now, it's a little tedious, it's a lot of detail. It's real easy to make a mistake and get the wrong answer. Okay? But the point for the graph that we're making, the graph of this function is this x cubed dominates everything else. If x is 1,000, then this is 1 billion. This is 15 million. That's 15 thousandths or 1.5% of 1 billion. And the rest of these don't amount to a hill of beans. The bigger x gets, the less these matter. Okay? So if we zoom out like I did over there, this is like x cubed. What's x cubed look like? Make sure you know how to construct that. Because there is a problem in the test where I ask you to construct the graph of a power function. Could be x cubed, could be x to the 4th, x to the 5th, x to the 6th. Probably wouldn't go over x to the 6th, but review what we did in class. You can start with a table. And you're going to find that when you get to 1/2, you get really tiny numbers. And when you get to x equals 2, you get really big numbers. Using the idea of a flattened graph, and if you graph it carefully, you'll understand. And if you understand that, then you understand that what we're looking at here is zoomed in. these are where the wiggles are going to go. That's this little region here near the origin. And now we zoom out so we can see what happens with the wiggles. What we know is that the x cubed graph goes up here, goes down here. Now, if it was a negative x cubed, it would go up on this side and down on this side, but that's just a reflection through the x-axis. You should understand that. Okay. So this means long run is here. Long run is here. And what we're doing here is long run. It's not necessary to do all this multiplication, but you do have to understand this because you will have to do it. Maybe not even on the test, but you will have to do it, and probably in the final exam. So you should be able to do one of these. The point is that when we write it like this, ultimately, each one, this x will multiply this x, will multiply this x. Now, first, the way we did it, this x multiplied this x right here, gave us this, right? Okay. And then this x is going to multiply those two x's to give us x cubed. That's it. We just count how many x's we have if we break this into linear factors. How many x's are multiplied together, and we figure out what our long run function is going to be. If it's an even power, it's going to look like this. The higher the even power, the flatter it's going to get, but it's going to look like this. And your long run is going to be either up on both sides or down on both sides. Feel like you had a negative x to the fourth, okay? And if it was a negative x cubed, of course, you'd reflect this. But at being x cubed, if you cube a positive, well, if you cube a negative, it's negative. If you cube a positive, it's positive. An odd power of a negative is negative. An odd power of a positive is positive. That's the explanation for these two graphs. Make sure you understand that. Don't just memorize the idea because you get it confused. Okay? Okay. So there's our long run behavior. It's got to either do this or this here. Well, it's going to come up from below. And the first time it's going to hit the x-axis is going to be right here. Because remember, these are the only points where it can hit the x-axis. If x is any other number, neither of these is going to be zero, and you're not going to get zero. And it's not going to be a y equals 0 point. Okay, so we come up from down here. Let's go ahead and use a distinctive color. So we'll come up from down here. And we got to turn around here. So it's like this. I just drew those in lightly. I'll go ahead and erase them, but I had them there to remind myself that this being of degree 2 or multiplicity 2, it's going to act like x squared. Okay. Because where did this come from? It came from this. X plus 5 squared is x squared shifted 5 units to the left. X squared graph shifted 5 units to the left. And because x minus 2 is negative here, it's flipped around. Okay. Now we come around here. Now we're going to go through here. Now we're not just going to head for this point. We're going to actually probably come down quite a ways below this point before we come up through here. So we can come up through here with a nice graceful curve. I won't claim a whole lot of grace. I've got a little wobbly there. You get the idea. Okay, there's your graph. Now, this graph wiggled twice. Okay. This graph wiggled 3 times. In other words, it turned around here, turned around here, turned around here. We said there are three turning points on this graph, which might not be all that visible. Okay, it's kind of lopsided there, but you see we got a turning point here, a turning point here, and a turning point here. It's got to turn 3 times to get through those zeros. This one only had to turn twice. Well, this function had 4 zeros. To get through 4 zeros, you got to turn 3 times. That's all there is to it. Okay? Now, this one had only 2 zeros, but one of them had multiplicity 2. And that caused us to have to turn there, and now we turn here. The general rule is, whatever the degree is, if it's an x to the 4th, you're going to have 3 turning points. Maybe less. Just plain old x to the 4th would have only 1 turning point, wouldn't it? It doesn't have any wiggles. If it's just y equals x to the 4th, that'd be pretty simple. Okay. But you can have at most 3 wiggles for degree 4. You can have at most 2 wiggles, 2 turning points for degree 3. Open math tells you that very clearly. Okay. That's kind of the core of what you need to understand about polynomials. However, what if you were given the polynomial in this form and you didn't know that it came down to this? What would you do then? Well, it turns out that that's where you got to understand long division. So I'll tell you what you would do if you were given this function. Just so you know why we learn long division. Okay, so let's say we've got y equals this, x squared plus 15x, it's x cubed plus 15x squared plus 75x plus 125. What we do, and you'll see why in a minute, is we had this and we didn't know anything else about it. We might try x equals -1, x equals -2, x equals -3 to see if we get 0 from one of them. Now, in general, if you got pluses and minuses in here, you'd also try x equals 1, 2, 3. Those are small numbers. You might get lucky, and one of them might give you 0. Okay? In the real world, if you got a polynomial that comes out in the real world, and the chances are that you're going to find a 0 by doing this is practically 0. Okay? It just doesn't happen in the wild. But in the ideal case, it does this, and it's kind of important to understand this. So let's see what happens. Okay, now if x equals -1, Well, I'm not gonna do the arithmetic. You can do the arithmetic. -1 cubed is -1. -1 squared is 1, and you multiply that by 15, you get 15. If x is -1, you're gonna get -75 here, and you're gonna get plus 125, whatever x is. Okay? Well, pretty clear that that's not zero. If you add up the positives, you get 140. Add up the negatives, you get -76. -76 and 140 isn't zero. You can see that these numbers are gonna add to something bigger than 100, and these are gonna add to something less than 100. And all you gotta be able to see is that the positives don't add up to the same thing the negatives do, okay? Now, okay, well, let's say -2 cubed is -8. And -2 cubed is 4, so we're gonna have a plus 60. And then we're gonna have -150. That's 125, and that's not quite zero. We get -158 and 185, which means that for the first time in my life, I made a mistake. It means when I did all this algebra here, like I said, when we do this, this is easy, but it gets tedious. It's easy to make a mistake. Apparently I did. Okay, so I'm gonna fudge it, I'm gonna cheat. And I'm gonna say, that's -150. This has to be 150, so I'm gonna change this number. So this is no longer the number we got here, no longer the polynomial we got here. But we're gonna make this 98. Uh-oh. The brain doesn't appear to be wired any better or worse than usual. It should be 108. No, it shouldn't. It should be 98. What's the matter with me? Look at these numbers. Okay. 60 and 98 makes 158. -8, -150 makes -158. Okay. So this equals 0. Aha. This means that x cubed plus 15x squared plus 75x plus 98 equals x minus -2 times something else nice. And that then equals x plus 2 times something else nice. It has to, because if x equals -2, it's 0. It's equal to x minus 2 times something, nice or otherwise. But if x is -2, this is going to be 0, so the whole thing's going to be 0. Well, again, let me see how we're doing time-wise. Again, X plus 2 times that something nice has to equal this. So nice equals x cubed plus 15x squared plus 75x plus 98 divided by x plus 2. You know, we divide both sides of this thing by x plus 2, right? If two numbers multiply out to this, then the first of those numbers equals this divided by the second. Like 2 times 5 is 10. So 10 divided by 2 is 5. Okay? It's just division backwards multiplication. Again, a sense that people don't have as well as they did before we put calculators in their hands and they never had to think about what division meant. Okay? So we have this, and we're trying to find nice. Well, what we do is we divide x plus 2. We do a long division. Okay, well, you probably remember long division from 5th grade. Forgot it immediately as soon as they put a calculator in your hands, which is kind of tragic. Okay. You know, your brain works better if you understand a somewhat challenging algorithm. Okay. Now, that's not all that challenging of an algorithm because we teach it to 5th graders. Okay. But bypassing the necessity of learning that deprives people of the ability to think in certain ways. Now, if that's replaced by the ability to think in more profitable ways, which is the whole goal, then it's kind of okay, but that's not how calculators are being used. Okay, at least not in most schools. X plus 2 divides this. Okay, well, if you divide x into x cubed, you get x squared, right? And let's just do a division. Let's say you're trying to divide 15 into 597. Okay. You got to try to divide 15 into 59. How many 15s go into 59? Well, if you know your numbers, 15 times 4 is 60, and that's not quite 4. So you're going to say, well, okay, 4 doesn't work. We're going to put 3 here. 3 times 15 is 45, leaves us 147. How many times does 15 go into 147? Well, 15 goes into 150 10 times, so it better go into 147 9 times. So we do 9 here. 9 times 15 is 135 with a remainder of 12, or 39 and 12 15ths, which is 39 and 3 and 4/5. Sorry. Okay, if I did that right. If I didn't, does that look familiar? Remember doing that some long ago time before they took your brain away from you and gave you a calculator? Remember now they're going to take your brain away from you and give you AI. Be careful. Make sure you're using your brain and not AI. Okay. So anyhow, we get x squared. So just like we multiply 3 by 15 to get 45, we multiply x squared by x plus 2, giving us x cubed plus 6x. What did we do next? We subtracted this from this, just to see how much more we got to get. Yeah. So we're going to change the signs here. I'm going to put a little negative sign. I'm not actually going to change it. I'm just going to put a little negative sign here and here to remind ourselves that we'd better be subtracting these things, right? Well, x cubed minus x squared gives us 0. This gives us 9x squared. 15 minus 6 is 9. And we'll write the 75x here because we still got to get once we got an x squared up here, we've got everything but 9x squared plus 35x plus 98. Okay? So you got to see what it takes to get a 9x squared. Now, well, x goes into 9x squared 9x times. 9x times x is 9x squared. Then we've got 18x. We put a little minus sign here, the minus sign here. This gives us 0. This gives us 57x plus 98. So we write 57, because 57 times x is going to give us 57x, but then that's going to be plus 114. And doggone, it didn't work out. I don't see a mistake, so it looks like I made a number of mistakes. But anyhow, this gives us a remainder of negative 16. Now, this was supposed to come out even, and if it had, then we would see that this equals this times this, okay? And the advantage that gives us is if it was this times this, then to make this 0, x would have to be -2, or x would have to be a solution of this. Now you got to see that. Okay, the assignment for next time is long division. Let me double check that to make sure. If I'm wrong about that, I'll change it, but yeah. Okay, the assignment due yesterday, which a lot of people at least started, some people made some pretty good progress on it. The assignment for yesterday was graphs of polynomial functions, okay? You want to get that done. Go to the half credit page if you didn't get it all. If you got better than half credit on it, then I'm just going to put notes into your assignment, and you want to pay close attention to those notes. Then you probably ought to go for practice or the half credit page and do them, because if you don't do these and write them out, I'm afraid you're not going to retain it, okay? So for next time, that's all you've got, and that's a pretty straightforward assignment. Now, you're probably not going to totally understand it from this, but open math is going to give you plenty of information. I'm still trying to figure out why this didn't work out, because x is -2 should give you a -158 plus 158, so that should have divided. I don't know. In any case, that's the process, and you'll see how it can be used to help you factor a polynomial. We'll talk about that next time. And you're going to have an assignment over the weekend where we actually use this, so make sure you're conversant with long division. It just takes practice. And unlike a lot of the other stuff, you don't really need to understand why this works, just be able to do it. They also show you synthetic division, but when I test you, I'm going to want to see long division. Long division actually has an explanation that you could understand, and I'll probably give it in case you're interested. But you don't really need to understand it if you understand the process. Once you understand the process, I can explain to you a little bit about why it works. But most people never know why it works, they just do it. And synthetic division is just changing long division a little bit. It gets even further from a direct process that can be understood, okay? It works. It's a shortcut. I want you to understand long division. Just for the benefits for your thinking process, and so you understand the mathematics actually a little better. So I recommend when you do this homework in the next couple of assignments, you use long division as opposed to synthetic division. And sometimes you just buck out to use synthetic division. I'll say more about that later. Okay. Test is in the testing center. It's due a week from today. Okay. And after you take the test, you should email me to get your results. Okay. Okay, well, good luck with that. And if you have questions related to the test, we can talk about them next time. So if you come in with questions, we'll spend some time on them.